My base's power demands keep expanding infinitely, so I'll just have to expand my power infinitely. But trapped up here in Skyblock means I have limited resources. Or do I? I still have the sun! The infinite beaming power of the sun itself is what I will harvest in order to power my base into a new age of technology. But in order to make the ultimate Solar Panel 6 powerful enough to harvest ludicrous amounts of energy, I'll need ludicrous voltage energy hatches, which all of my current machines are too weak to produce. So we're going to need help from a new multi-block friend. The time for the LUV assembler is here, and that means we'll need the power of our friend the assembly line to create the microparts needed to craft it. No longer are mere assemblers powerful enough to create the ultimate tier resources we need. Only the power of the multi-block made from nether stars can achieve our goals. But with our new auto-crafting setup, all we'll need to do is encode recipes for the various bits, bobs, and bolts needed for this guy. Laminated glass, however, is a bit of a detour for us because we need the forming press to make it, and I don't want to make a new material press multi-block for it, so I'll just quickly add a simple IV tier forming press and pattern provider setup to accommodate it. We also need to encode all the recipes for the plastic sheets it uses, and that requires me to add a new large chemical reactor to the automation floor, as we need to account for crafting circuit number 2. And then I discover there's a recipe bug in that you can't make tempered glass inside of a large arc furnace for no reason whatsoever, so we have to use our EBF instead, which sucks because it doesn't parallel and it's a lot slower, and we're less than 5 minutes into the video and glass is already a problem. Well, assembly lines are a real special multi-block as they refuse any input ports larger than ULV, which only have one slot. So if a recipe needs 5 different inputs, the assembly line needs to be 5 inputs long. So I'm gonna play it in the middle and go for 10 inputs. That should be enough for a while, I think. And good God, is this expensive. In fact, we're even missing patterns and passives that we need, like a supply of neodymium, very important for the future, so I hacked together another ore processing factory running barium and sodium persulfate to net us loads of neodymium. Also, the tag-based exporter on our freezer broke for some reason, so that sucks, but I'm sure I'm not going to have to fix that in the most menial and annoying way later. Our biggest bottleneck for the assembly line craft is the EBF, of course, slow thing as it is, so I've got some waiting around to do. Oh.
Honey?
Yeah?
It's been days.
It's been Gregtech. Okay, we've hit ourselves a bit of a snag. Assembly lines need a special input called a data access hatch to run their recipes. You see, we need to research recipes and encode their data into the assembly line before it can use them. And the data access hatch must be made in an assembler inside of a clean room. Our big assembler is well outside of our clean room, so I need to whip together a new single assembler and jam it into the IV lines inside of the clean room just to make a glorified USB drive. I love you, Gregtech. But with that out of the way, we can finally begin to work on our newest friend, Sir Assembly of House Line. This monster machine is made up of Netherstar-powered casings, overclocked to LUV power, and equipped with 10 item inputs and 9 fluid inputs, sleek laminated glass, and of course, a new age data hatch to store up 9 whole recipes worth of data. Yeah, only 9. Did I mention this is not the only assembly line we'll be making today? And in order to run this guy with AE auto-crafting, we need to treat every single one of its inputs as a large subnet. But of course, do I manage to make it work? Probably not, but let's find out. The first thing we have to craft is the LUV electric motor, so first we gotta research it. For now, research is pretty easy. We just need a scanner machine and a data stick, and to learn about the LUV component, we just pop in the IV component. So data stick and IV motor go in, data on the LUV motor comes out. Then that data goes into the data hatch, and we can encode the recipe and apply it under logistics. LUV is monstrously expensive. In fact, we're even missing a vital metal for it, Sumerian, which we can only get through centrifuging rare earth. And there's only a tiny chance of getting 1/4 of a dust anyways. So it's kind of a good deal that we already have quite a lot of rare earth lying around from previous ore processing. And after blowing through 4 stacks of the stuff, we don't even have a stack of samarium. So that's gonna need a passive at one point, but that's for future DJojo. For now, we can send the craft to our first LUV motor, and it doesn't work. Okay, well, it's got all the items and fluids and... Oh, right. The assembly line is really picky, and it needs its inputs to be in order from front to back. Okay, we can change all the priorities on the storage buses to force the items to come out in order. Also, side note, if you're doing the assembly line, make sure to output from the assembly line back into the pattern provider and then use the pattern provider's crafting block. It'll help you. And while I get to test the assembly line a second time, guess what? I get to fix the freezer in the most tedious and menial way possible, since tag exporting just doesn't work anymore for no reason. Well, at least the assembly line works now. Hello, new friend. And if we can make motors, we can make just about everything else. So let's get that LUV assembler in our hands. Just got to encode a pattern here and here, sign on the dotted line, wait 20 minutes in real life, and bam! LUV assembler, baby! Can't use it if it isn't powered, so we'll need to smelt up some twinnite ingots, which I'll use the ABS for, since it'll make the molten form of them in bulk and free up my EBF for other things. It's made of simple dusts that we can easily autocraft, and with a puff of helium gas for heat, we can just leave those little ingots to bake for a bit. Just long enough to snatch a 4-amp LUV converter for the quest book, which is more than enough to power just the assembler, which we'll be using to make one single item, and then never again. A ludicrous voltage coil. Well, 2 of them. With these in hand, we can now make LUV energy hatches. Slotting one into our large assembler powers it into LUV, and now we can autocraft the coils, which means we can autocraft the energy hatches. So I make 2 more and push them into our ABS to power it at ZPM, unimaginable heat, and speed, and energy consumption. Right, the whole reason we're doing this. Solar panel 6. We're already down 20 billion units of power from our bank, so I better get to encoding the recipes we need fast. And to upgrading our machine line to LUV for even more speed at crafting. I gotta disconnect the ZPM power from the ABS because it really is excessive, and I'd really like to stop blowing up my IV energy hatches too. That would be nice, so nice. But after a few more upgrades, including a ZPM powered EBF, we can begin the craft of our first solar panels. 4 of them will make 1 full amp of ZPM power for us, which is about 600,000 FE per tick. The craft, however, is going to take a really long time. The solar panels need a part called an energy core or something like that, and they need over 30 real-life minutes in the polarizer at the tier of power we're using right now. So I'll make it a mental goal of mine to get ours to ZPM power to quarter the time that they'll take. I use this insanely boring moment to craft up a massive rhodium-plated palladium smelt, as it's the LUV metal, and passive some lava and liquid blaze, since I really should have done that from the start. I don't know why it took me this long. And still, it takes ages to finish the craft, but in the end, we end up with 4 beautiful solar panel 6s. Even just these 4 little blocks push us from 60 billion units of power in the red to profiting 500,000 power per tick. Now, we can afford to push the rest of our machine line to LUV, a massive speed increase to things like HPIC wafers and circuits. With all of our machines at LUV, but we're still far from our goal. Sure, we have lots of power now, but it's not infinite. I can't just request a stack of these whenever I want. It'll take way too long, and we barely have the resources to support it. If only there was a way to speed things up. If only there was a way to go even faster. Well, we could, but we'd need ZPM tier. If we could heat our EBFs up even more with better coils and power them even harder with better energy hatches, their bottleneck would fade away. In order to achieve ultra voltage power and crazy hot trinium coils, we'll need to create the fantasy metals of Naquata and trinium. The Naquata processing line begins! I shore up our solar panel supply to support the power requirements we'll meet, and even do some shopping for multi-block hatches. I then clean up the area nearby the agricultural setup to use as a site for the Naquata processing line. It begins with a large chemical reactor that takes in an item in a fluid and has 2 fluid outputs, and I'd like the setup to be relatively clean, so I end up placing and breaking the LCR a few times to get the alignment perfect, just the way I want. And we end up with 3 large chemical reactors, each outputting into another, working together to combine hydrogen and fluorine for hydrofluoric acid, and then combine hydrofluoric acid with antimony trifluoride to make fluoromantic acid, and then fluoromantic acid with Naquata dust is the final LCR step and the core of the Naquata line. But before we can do any of that, we actually need antimony trifluoride, which thankfully is very easy to make and fully recyclable. So once we combine the fluoromantic acid and Naquata, we get 3 things. A dust that can be smelted into titanium, impure enriched Naquata solution, and impure Naquadria solution. The 2 solutions eventually get processed into their respective ingots, as well as tritium ingots and a supply of indium phosphate 2 through a series of centrifuging and distilling and sending liquids around. And all of this is powered by some elegant applied energistics connections. Interface spam. With this somewhat compact knot of machinery, we have the Naquata line fully passived, but no dice on smelting it, as tritium, enriched Naquata, and Naquadria need higher tier coils than we have to smelt. Naquata coils is the next step in coil technology, which we'll use to be smelting trinium and enriched Naquata. And thankfully, they're actually pretty cheap, just needing a smelt of good old Naquata dust, which we have in droves, and so that gets a little dip in the EBF. We'll also need some more energy hatches, converters, and of course the coil, so I've got some waiting around to get to. Thankfully, my editor is about to do a super cool transition to convey the passage of time. Once our hatches and coils are done, 2 more EBFs hit the factory floor, one smelting zinc dust and tritium sulfide to make uber important tritium ingots, and the other smelting the enriched Nequata sulfate to make us enriched Nequata. Our energy consumption is now completely uncontrolled, so I do need to put a few more solar panels on the line, and, well, now there really isn't anything we can do until we have a bunch of tritium ingots. Yes, tritium is the key to all things going forward, I fear. Tritium will be our greatest bottleneck. Well, there is actually one thing we can do. In order to make the ZPM energy hatches I desire, regular scanners are not going to cut it for research. We'll need the research station, a complex multi-block that we should be able to craft up, I think. But you know what they say, the only way to learn is to cause massive radiation. Yes, to make the research station, we need our hands on a steady supply of uranium, which means we have to process pitchblende ore. By electrolyzing pitchblende dust, we can get our hands on uraninite, and uraninite combined with hydrofluoric acid and fluorine makes us a substance called uranium hexafluoride. We can spin that down into enriched uranium hexafluoride and depleted uranium hexafluoride. The enriched uranium hexafluoride gives us ultra radioactive and completely useless uranium-235. We want the depleted stuff, just regular old uranium, which is the only one that can be used in our alloy. And before we make our research station, I'm going to craft an LUV sensor right on its own for quest completion purposes, and then turn that sensor into an LUV scanner. But we're not going to scan anything with the LUV scanner. Instead, we're going to scan the LUV scanner to learn about the research station. So, actually, hopefully we don't need to use that later. Now, the research station needs an assembly line to make, and our current one is running out of space in it, so I gotta make another one. Well, that wasn't fun to do again, but it sure is handsome next to its sister. And then we can fill it with our research and begin to encode patterns, and then the roadblock. The research station needs ZPM parts. ZPM parts need europium. Europium. A metal so fantastic, it requires a particle accelerator to synthesize. That is going to be expensive. Like all good things, the Mark I reactor requires a load of recipes to be encoded, and we even get to add in the Nequata tier of silicon wafers to get things ready. And
narrator.
Jesus,
Narrates all.
jump scare. Oh my god,
Game
no
menu.
idea how I did that.
Use
but I
mouse
was locked in
cursor
so
or
hard,
tab
and that
button
just
to select
narrator
element.
narrates chat.
Options.
Ugh, scared the hell out of me.
Access.
It interrupted me adding a parallel ore washer to the processing line to make getting Certus quartz automatable. I'm not sure why I didn't passive it, but I don't know, I'm tired. We still need borax from salt processing, so in goes another ore factory breaking down salt ore. And after encoding so many recipes that I can feel my brain internally swelling, we're still not able to make a Mark I reactor, because of course we need plutonium to make this thing. So we gotta go make a nuclear power plant. Let's go, baby! The reactor recipes are pretty cheap for us actually, as we're well past the progression step for it, but while making it, we run out of hydrogen. Ugh. Fine, alright, we'll see if I ever run out of hydrogen again after I add a parallelized electrolyzer running at ZPM power, splitting water into hydrogen and oxygen. That should do it. Anyways, nuclear reactor time. Bam! It's a big old box. It'll make power for me, but I don't care about that because I already have power. What I want is plutonium, which of course we get from uranium. We can make uranium fuel rods in a canner and run those in the reactor with some distilled water, which will eventually spit out depleted uranium fuel rods, which I probably shouldn't be holding in my bare hands. But if I spin them around at massive speeds, we can get 4 plutonium dust out of it, which need to be spun down again for a small chance at producing plutonium-241, which we'll need 2 of. Who knew spinning around was so productive? In short order, we've got our 241 that we need, and now we can finally make a Mark I reactor after handcrafting some phosphorus dust and, tritium. Yes. The reactor is expensive, like really, really expensive, and by my math, I need to wait a few more real-life hours before I have enough tritium. So I may as well queue up a stack of solar panels and then just, I guess, take a nap. Greg reactor. Oh, it's done. Ding! The parts are here. And it's a pretty annoying one to build, so I'll use the terminal to instantly... Okay, never mind. I'll build it by hand. Oh, and I can just taste the europium. Well, actually, I probably shouldn't, but wiring and piping this thing is a project, as it has 16 energy inputs, fluid inputs, and fluid outputs, all of which want to be one big happy family. And after jamming this into applied energistics, we can request our first batch of europium, and it works! Ooh, it works too well. Okay, don't stand inside of the particle accelerator. Man, that's my first death on this world. but also our first ingot of europium in this world too, and that removes a final roadblock to entering ZPM tier technology. Research begins on ZPM tier microparts, as does recipe encoding. And god is it satisfying to watch my crafting line light up as we queue an entire ZPM assembler in just one click. Just look at that assembler go. We'll also want a converter for the assembler, which wants dragon steel wires, a blend of twinnite and shellite that takes pretty damn long time to smelt, but once it's done, we can finally power the assembler and create 0-point module coils, the final ingredient to ZPM energy hatches. Oh, well, and I also need to research them. Right. High-tier research is a multi-step process that I admittedly didn't really know how to do, but what I did know is that I still needed to encode more recipes, and that we're running out of assembly line space, so methinks I'll juggle the data sticks for the crafts we need. Unlike the simple scanner blocks, the research station must be fed a special energy called computation, which I'm going to refer to as learning juice, because what else would it be? To make the learning juice, we need the HPCA multi-block, which, no joke, is one of the most expensive machines we'll be making today next to the particle accelerator. Partly because it needs the uranium-rhodium dinaquadide alloy, which requires the heat of tritium coils to be smelted. I've already established the expense of tritium, and we don't have any ZPM energy hatches, so we have to make the coils by hand inside of the ZPM assembler like plebeians. Instead of the 16 needed for an electric blast furnace, I make 24, enough to upgrade our alloy blast smelter since alloys is what we need. And while the coils get assembled, some of our HPCA parts arrive packaged nice and neat for us, and I won't make you wait as long as I had to begin building a big computer. It's actually a pretty cool concept for a multi-block because instead of just inputs and outputs, you have to balance computation generators that create heat and coolers to offset them. It's admittedly simplistic, but it's pretty fun. For now, I aim for a small amount of learning juice generation, but I don't know how to store it. Now, future DJojo knows you can't store learning juice, but past DJojo didn't, and wasted an astronomical amount of time and resources creating the data bank. It's not meant to store learning juice. So onto the research station, which I waste no time in queuing up the absolute mammoth craft for. And in no short order, we can boop our research station into existence right next to our HPCA to make cabling learning juice really easy. The first thing I want to use this guy for is actually the advanced data hatch to expand the storage of our assembly lines, so in goes a regular data hatch and a data orb, and it gets to learning. It doesn't take too long to finish, but I'll definitely want to upgrade it with more computers and coolers, so I do just that before popping in an LUV energy hatch to learn the recipe for the ever-coveted ZPM1. And god, what a good feeling is it to craft 2 ZPM hatches to begin our ZPMing journey. As always, the first one goes to the assembler so that we can make the 0-point module coils automatically, and the other goes to the circuit assembler, because faster circuits is always better. And I really should stop blowing up my energy hatches, but I would still like to replace them. So with a few machines at ZPM tier, I queue an enormous craft of 32 energy hatches, 2 stacks of dragon steel wires, and a big 16 amp ZPM converter to power everything. And good god, is it a massive base upgrade. I even throw new EBF coils into the mix and make a new set of wire cutters out of Naquata alloy for faster than netherite mining speeds. And then the ZPMing of the auto-crafting line begins, each machine doubling in speed, and the polarizer gets its customary overclock up to ultra voltage. We can now make 4 ingots of Naquata alloy in 13 seconds, and our dragon steel craft has dropped from 800 seconds to 200. We're consuming so much power that we have to bypass limits on our flux points from now on, and the best part is we have the solar panels to support it. I pushed the freezer to UV power as well, and that marks all my machines at UV or ZPM, but they can yet go faster. We've now unlocked a new tier of parallel hatch, 64 times parallel. Stupidly high numbers. But we'll need better circuits. Circuits made of crystals. And for that, we'll need to move our autoclave into the clean room and get our hands on some exquisite emeralds and liquid europium. We can grow raw crystal processors from the emeralds and europium, and raw crystal processors can be infinitely duplicated from just one. Each chip can be smashed into 9 chips, each of which grow into a full processor, and I decided to bulk up nicely on the fellas. Once I've got a happy amount, the processor's gonna dip in the EBF with emerald plates and helium to make engraved crystal chips. That gets a lime laser ring to turn into a crystal CPU, and then a blue laser ring to make a crystal sock. Yeah, that's right, we're skipping right to the sock. In order to make the crystal circuits, I find myself in need of the yttrium-barium cuprate alloy, which needs card 14 on our ABS, but we're out of blocks to use for inputs. Luckily, we can cleverly route multiple pattern providers into the same nanupal fluid hatch to save on some space and just barely eke out the inputs required to run crafting card 14. With that, the first of the crystal circuits is ours. We can make all the way up to the ZPM tier circuit, the supercomputer, because the mainframe is the first UV circuit, and it requires research. We also need to double the research power than we currently have, so I need to upgrade the HPCA again. The upgrade is severe enough that we have to use advanced coolers who require cooling fluid to operate, but I didn't want to passive it, so I just crafted a lot of it at once. Don't do this, that was a bad idea and done by a professional idiot, because I don't make enough of it and most of my computers burn up and turn into empty HPCA blocks, so I have to craft them again. But the upside is I noticed palladium ingots are now smelting instantaneously inside of our EBF, which is super cool. I still don't passive the fluid though, I just make a lot more of it. And this time around it actually works. We researched the first of the UV circuits and are able to send their crafts into the system. With these amazing circuits in hand, we have the power to create unimaginable machinery, things that can draw complex chemicals out of the air itself. But all I want right now is that sweet, sweet parallel hatch. So I make sure to encode the data we need for ZPM tier sensors and emitters and queue the craft for 4 ultimate parallel hatches. And honestly, the craft took less than 30 minutes, which was way better than I was thinking it would, so big win for me. I used them to boost the machines in the clean room since those are usually the bottleneck, and now they work so fast that it takes less than a minute to make just 1 parallel hatch. Well, save for all the europium, because that's just gonna be my eternal torment.